Bridges and large-scale infrastructure are among humanity's most enduring expressions of intelligence and ambition. Long before written history, humans sought ways to cross rivers, valleys, and unstable ground. These early efforts were simple but revolutionary. A bridge is more than a structure. It is a decision to connect, to expand, and to reshape the environment in pursuit of movement and cooperation. The story of infrastructure is the story of civilization itself. In ancient times, bridges were built from stone, wood, and rope, relying on gravity, compression, and empirical knowledge. Roman engineers perfected arches and road networks, creating structures so durable that some still stand today. These bridges were not only functional, they were symbols of power, permanence, and order. Infrastructure defined the reach of empires and the limits of control. As societies evolved, so did materials and methods. Medieval bridges combined engineering with defense, often integrating gates, towers, and marketplaces. Infrastructure became a social space as much as a technical one. Roads, aqueducts, and canals expanded trade and communication, binding regions together and accelerating cultural exchange. With the industrial age came a dramatic transformation. Iron and steel replaced stone, allowing bridges to span greater distances and carry heavier loads. Railways demanded precision and scale, and infrastructure shifted from handcrafted permanence to industrial efficiency. Suspension bridges, tunnels, and massive transport corridors reshaped landscapes and cities. Engineering became a science governed by mathematics, standards, and specialization. By 2025, infrastructure exists as a layered system. Bridges are embedded with sensors, monitored continuously, and designed for both efficiency and resilience. Highways, rail networks, power grids, and data cables form invisible skeletons beneath daily life. Infrastructure is no longer noticed until it fails, yet it supports nearly every aspect of modern civilization. As the future unfolds, infrastructure becomes increasingly intelligent. By the 22nd and 23rd centuries, bridges and megastructures adapt in real time, responding to stress, climate, and usage. Materials self-repair, loads are redistributed automatically, and failures are predicted before they occur. Human engineers shift from builders to system designers, overseeing networks rather than individual structures. Further ahead, around the year 2600, infrastructure reaches continental and planetary scales. Transport corridors span entire regions, integrating land, sea, air, and near-space movement. Cities are no longer isolated nodes but components of continuous engineered systems. Infrastructure begins to shape human behavior as much as it responds to it, guiding movement, settlement, and resource distribution. By 3600, the boundary between infrastructure and environment begins to dissolve. Artificial landmasses, floating structures, and orbital platforms are connected through vast engineering networks. Bridges no longer merely cross obstacles. They define space itself. Infrastructure becomes an extension of planetary management, balancing energy, ecology, and habitation across vast areas. Finally, by the year 5500, large-scale engineering transcends traditional form. Infrastructure exists across planets and orbital zones, linking habitats, energy collectors, and transport systems into unified megastructures. The concept of a single bridge gives way to continuous connectivity. These systems are not monuments but living frameworks, evolving alongside the civilizations they support. The evolution of bridges and infrastructure reveals a deeper truth. Humanity does not simply build to survive. It builds to connect. Across millennia, materials change, scales expand, and purposes evolve, but the impulse remains the same: to bridge gaps, overcome limits, and reshape the world in pursuit of movement, unity, and possibility.